Hello, welcome to another free code session. My name is Jason Bach, and I'm going to continue riding the pony, so to speak, learning about this pony language. So we just got through classes. You can see I was playing a little bit with, with classes here, and also the main method, and you had to have an actor main, but we can have a class wombat, and this is private because of this, and this is just a differentiator. I could probably have called, I'm calling the hungry function, so I could probably just call this quux, and it wouldn't matter. That would be just fine. The tick is just like a differentiator. I'm guessing what you can't do, because there's no difference between these. There's no this or something. Yeah, I can't reuse the name. Okay. That makes sense. Okay, so it's just a little thing. This is a function. It actually returns hunger. This one will actually return the old value when you set it. And actually, let's try that. Let's say environment.out.print. Now, I don't know if it's going to do coercion of an U64 here. Hungry wombat dot set hunger. We're going to set it to, let's half it to 500. Okay. And then let's out print hungry wombat. Let's get, and I can't say hunger level because it's private. I could do name though. That's why that was okay. Hunger. Does that work? Argument on a subtype or parameter. Oh. I thought it said it returned the... I thought it said there's an old value of hunger level. So it does return. That's a little confusing because if I was misunderstanding this then. That string val array thing there looks very similar to TypeScript's type unions. Does that work? Huh. Argument type is C64. Is it like a two-stir on a U64? Two string? I'm just guessing here. I have no idea. You can find two string. Yeah. Okay. So that doesn't quite work. There's got to be a way to do it though. So if we just did this, let's running. Okay. Let's go back to learning. Okay. The class is primitives. Primitive is a similar class to critical differences. It has no fields, one instance of a user-defined primitive. They're never mutable. Yeah, that makes sense. Single instance, primitive type, it always gets the same result back. We can use a primitive for as a marker value. Primitive none, no value. Of course, it does have a value, and the value is a single instance of none. A union of primitive types, you can have a type-safe enumeration. Okay, so there's such a thing as union types. Collection of functions. Primitives can have functions. You can group functions together in a primitive type. You can see this in the standard library where path handling functions are grouped in the primitive path, for example. Two marker values. Those are... Oh. I guess it's just the definition of a type. Oh, this feels definitely like TypeScript. I wonder when this language was made. If they were borrowing some stuff from that. But languages borrow from all other languages. So let's actually copy this, because I want to learn. So what I'm going to do is actually I'm going to take this. Let's put it in here. And save it as... let's go into my code projects. Let's create a pony code. Well, we know it's that. Name is wombat.pony. All right, so you can just clear all that out because I want to learn this. Primitive opened door and closed door. So we have a primitive opened door, not door, and primitive closed door. And then we have a type definition of door state, which is a union of opened door and closed door. Okay. A collection of functions. So I have a primitive of basic math. And that's what they said about primitives, right? It has no fields. But it could be a collection of functions. Okay. 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 Primitive math. I think that's what they called it, right? Basic math. Basic function, which is fun. Add. We're going to add two U64s. A, which is a U64, and a B, which is a U64, which returns a U64. And what does that do? A plus B. Wow, I'm shocked. Fun multiply A, which is a U64, and a B. U64, which returns a U64. And well, you know it's A times B. Wow. Wow. I wonder what to do with overflowing. Whatever. We have to have our actor, which is a main. We have to have a new create env, which is an env. We're going to let is a read-only, door state. Let door state be equal to, oh no, I'm sorry, not, oh, and so you can actually put spaces here too if you want. I kind of like this door state, which is equal to a closed door. Now what? Let is door open, which type of a bool or boolean? Oh, that's a bool. Matched. Oh, nice. They got matches. Nice. Love it, love it, love it. We're going to match on whether it's an opened door, which means we do true, closed door, which means we do a false. End of the match. Okay, so now we're going to do env out print is door open plus, I wonder if they have interpolated strings. Oh, so you just say string. Okay. Is door open string. Right? And then we'll do this. 2 plus 3 is equal to, let me guess, basic math dot add 2 and 3 dot string. Right? Yeah. And let's run that. Very nice. So if we made this an open door, so yep, straightforward. But I'm liking this. I'm liking that they have these kind of options with enumerations. It's a little weird because if I want to make an enumerated type, I have to actually declare these separately. But whatever. We'll keep moving on. Primitives are quite powerful. Unlike enumerations in other languages, each value in the enumeration is a complete type, which makes attaching data and functionality in enumerations value easy. Built-in primitive types. Remember, all types have to start with an uppercase, so that's why this is that way. Yeah. I wonder if they have intrinsics as well. I don't know. We'll see. Bool, yeah. Integer, signed integers of various widths. Why do we have a nice size? size of t, which varies by platform. That makes sense. Okay. Bit width of the native type long. Okay. So it has an I-28. That's nice. And then a 32 and a 64 for floats. Okay. Primitives can have two special functions, init and final. Init is called before any actor starts. Final is called after all actors have been terminated. The two functions take no parameters. The init and final functions for different primitives always run sequentially. Okay, so to recheck, we have primitives. Can have no fields. Can be a collection of functions or collections of other types. Okay, that makes sense. I'm liking this. I like that they have this capability built in, and the matching. Oh, so sweet. Now that C, again, going back to my favorite language, the language I spent almost my time in, with C#, that they're now adding more powerful pattern matching capabilities by basically, amping up the switch keyword. They don't introduce a match keyword. They decided to stick with the switch keyword. So I'm not really sure why they did that, but is what it is, and you can start doing some more powerful things. But I just find this to be so easy to read. I don't know why. I'm liking it. Still don't like the underscore defining something to be a finalizer with underscore final or a private underscore whatever. Okay, but that's okay. Not every language is what you like, but as long as you know how to work with it. Let's move on. Actors. An actor is similar to class and have behaviors. So what's the difference? Behavior is like a function. The functions are synchronous and behaviors are asynchronous. You call function the body, the function is executed immediately. Right. When you call a behavior, the body is not executed immediately. So the body of the behavior will execute some indeterminate time in the future. Okay, that makes sense. Behavior looks like a function. Let's say choose the keyword fun. It's be. Funby. Be fun. Like a function, a behavior can have parameters. Unlike a function, it doesn't have a receiver capability. Behaviors always return none, like a function without explicit return types, because they can't return something they calculate, since they haven't run yet. I don't want to akin this to asynchronous, but well, it kind of is, the task in C#. But tasks can return types if you have a task of T. Wombats and aardvarks. Where is all this coming from? I'll type that in eventually, but I want to get my head around this a little bit more. If you're familiar with actor-based languages, like Erlang, which I'm not, of it, but I've never programmed in it, you are familiar with the concept of message passing. It's how actors communicate with one another. Behaviors are the pony equivalent. When you call a behavior on an actor, you are sending it a message. If you're feeling message passing, don't worry about it. We got you covered. Keep reading and all will be explained. Concurrent. Since behaviors are asynchronous, they run the body of a bunch of behaviors at the same time. This is exactly what Pony does. The Pony runtime has its own cooperative schedule, which by default has a number of threads equal to the number of CPU cores on the machine. Each scheduled thread can be executing an actor behavior at any given time, so Pony programs are naturally concurrent. Actors itself are sequential. That means each actor will only execute one behavior at a time. Right, because they can be asynchronously invoked, but they have a mailbox in front and they only get one message processed at a time. So you have to worry about concurrency. When you're writing Pony code, it's nice to think of actors not as a unit, but as a unit of sequentiality. You should do only what has to be done sequentially. Anything else can be broken out into another actor, making it automatically parallel. In the example below, the main actor calls a behavior, call me later, which as we know is asynchronous. So we won't wait for it to run before continuing. Then we run the method print, which is also asynchronous. Okay. So, okay, makes sense. And we'll print the provided text to the terminal. Now we finish executing code inside the main actor. The behavior we called earlier will eventually run, and we'll print the last text. Since all this code runs inside the same actor, and the calls of the other behavior in sequential as well, we're guaranteed that this is printed first is always printed before this is printed last. Okay. Why is this safe? Talk about function receiver. They are annotations on a type that make all the parallelism safe without any runtime overhead. Okay. Actors are cheap. Threads can be expensive. Context switches can cause problems. Stack. But actors are cheap. The actor cost of an actor as opposed to an object is about 256 bytes of memory. Bytes, not kilobytes. And there are no locks and no context switches. An actor that isn't executing consumes no resources other than a few extra bytes of memory. This pretty normal Larry Pony program uses hundreds of thousands of actors. Actors can have finalizers. Huh. I wish they would have had a little bit more complete example about Pony here with actors and message passing. But that's okay. We're going to move on. Traits and interfaces. Like other object-oriented languages, Pony has subtyping. That is, some types serve as categories that other types can be members of. There's nominal and structural. Pony has both. Yay! So this kind of subtyping is nominal because it's all about names. Discussion of single inheritance, multiple, mixed, and traits. These are all examples of nominal subtyping. The core idea is that you have a type that declares it has a relationship to some category type. You can implement an interface. Compiler check that the class actually provides everything it needs to. Pony has nominal subtyping using traits. A trait looks a bit like a class, but it uses the keyword trait and it can't have any fields, which is like an interface with default implementations. Here we have a trait named, which of course has to be capitalized because all types are capitalized. There's a single function name that returns a string. It also provides a default implementation of name. Returns a string literal Bob. Makes sense. Do they get down to like a... No, they don't. So I'm just going to type this in again because I think, again, typing helps. We're going to do this and put this into that. We're going to call it primitives. Pony. Primitive ponies. Pony primitive. Did you take? Yeah, you did. Okay. File new. So let's clear this out. Let's come over here. And we're going to be having a named trait. So trait named. We have a function, what was it called? Name, which returns a string. Which is going to have a default implementation of Bob. And then we're going to have a class Bob is named. Uses the one from the trait. Traits function doesn't have a default implementation, but I would complain that Bob had no implementation of name. So we can build this right. So we always have to have our actor name, not name, main, func create, taking an env of an environment. Is that legal? Let Bob equal Bob. env.out.print Bob name. Okay, what did I do wrong? Couldn't find apply. Okay. Back up. I missed something. Do you have to specify a constructor? New create. But what if I don't have a method body? let x, which is a type U6032, equals 0. I don't know. I'm really missing something here. Let that equals a Bob. I have a class Bob. I couldn't find apply in Bob. Why would you need an apply? You know, this stuff is important, though. This stuff isn't important. This stuff. New create. Give it a body. It's weird, though, that you have to have a body. What was if you have a method that just doesn't do anything? I don't understand what went wrong here. If I said y, which is a U32, and I said let x be equal to y, and I pass in 22 here, does it take that? Vector main. Oh, a new create. Okay. Bob. Okay, we got that to work. But that feels weird. That feels weird. Why? Well, yeah, now there isn't one here. But it's like, didn't it say something about... I thought I saw something where they talked about apply. Maybe not. Maybe we'll get to that later. That comes later. But right now this doesn't feel right. Like, why would I have to define... I guess there is no such thing as a default constructor? I don't understand. It doesn't take anything, so you should just be able to say bob.create, right? Okay, well, that works. So if it's a... that's a little weird, or I just don't have my head around it. Anyway, come back here to traits and interfaces. Yeah. That says it is named. Bob is named. Bob doesn't have its own name function. It uses one from the trait. The traits function didn't have a default implementation. The compile complained that Bob had no implementation of name. So, along those lines, that's okay. But now if I need a func of name, which returns a string, boom. Sense make. Okay, I can buy that. I can buy that. It's possible to have a class have a relationship with multiple categories. The class Bob provides both named and bald. So bald says you don't have hair. Name says what's your name. Okay. Bald could also be from named, and then Bob is bald and named. Oh. All bald classes are automatically named, yes. Consequently, the Bob class acts as both hair and named. As the bald category, to be more specific than the name one. Class Larry, name function, but Larry does not provide named, right? Because it doesn't say Larry is named, right? Traits are nominal. Traits are nominal, not structural. So it actually has to literally be is of that thing. Okay. And Larry doesn't. Now, structural say it does, because if you had structural typing, it's called structural subtyping. Type is built. Nothing to do with names. It happens to have all the needed. And this is actually from a book called Foundations of Object-Oriented Languages, Fool. And I've tried to go through this book like 3 or 4 times. And I get through the first half of it, and it makes sense. And then I get to the second half, and it's like it blows my mind. But that book was like the first time I really understood typing and subtyping and the notion of like, I don't know, call it duck typing, maybe that's what it is, but like this is where it's, you don't have to inherit from a type as long as you match the shape of a particular type. So you could have two classes that don't derive from a common type, but they have the same structural type as this type, and therefore they are a subtype of that type. And that just like, that actually made a lot of things clearer to me about typing. Not that I'm an expert in it at all, but that was just one of those things I'm like, oh, that's kind of cool. Concrete type. Yeah. Concrete type is a member of a structural category. It happens to have all the needed elements, no matter what it happens to be called. Go interfaces are structural types. I've never used Go, so I don't know that. Pony has structural subtyping too. So interface, so this is going to be a difference. Interfaces are structural subtyping. Traits are nominal typing. Subtyping. Okay. So it's an interface. Bob and Larry provide. Has name. Programmers over Bob and Larry don't even have to be aware that has name exists. Pony interfaces can have function with default implementations as well. A type will only pick those up if it explicitly declares that it is that interface. So it should use traits both. Interfaces are more flexible, so you're not sure you want to use an interface both. But traits are powerful too as well. They stop accidental subtyping. And we are going to stop there for tonight because that's an hour of me learning a new language, and that's about as much as my brain can take tonight. So, but I'm interested. I'm still interested in this. This is actually fun. I don't know when's the last time I've really sat down and tried to learn a language. And I did it with Rust about a couple years ago, and it just didn't click. And I don't know why. Having this, where you have this little playground here, does help. You can kind of play with things and go, oh, this is how some things work or don't. So that's actually kind of nice. So I'm going to stop for now, but maybe tomorrow night I will be doing some more things, and we're going to continue on the structs. This is kind of fun. So thank you all for watching. Leave comments and questions below. See you in the next episode.